Hey College Algebra, I'm recording this section 2.8 video right after I just did the 2.7, so I'm a bit winded already. And what we're going to do is hopefully keep this one short and sweet and do something called function operation and composition. And what it is we're going to add, subtract, multiply, and divide functions together. And then we're going to do something called compositions of functions. And then we're going to also determine these functions, new functions that we come up with. We're going to determine their domains. Okay, so let's get started real quick. So here are some operators of functions that we can do, just like adding, subtracting, multiplying, and dividing numbers. We can do the same to functions. What this right here means, this f plus g, then x right here, don't mistake that with times x. Never mistake that with times x. What this is the same as f of x plus g of x. So we're going to add this function to this function and simplify. Same goes with these functions. We're going to subtract them, then simplify. That's our new function, is those two added together, subtracted, multiplied, or divided. Here's how we're going to determine the domains of our new functions after we add them, subtract them, multiply them, and divide them together. So for the ones that we add, subtract, multiply, and add, subtract, and multiply, not divide, this is how we're going to determine their domains. And it's just going to be the intersection of our domain for f and our domain for g. So whatever the intersection means, the set of points that they have in common with each other. That's the intersection. And we'll look at that here in just a little bit in an example. Now, for our f divided by g, it's the intersection of those two domains, but where our function g of x is not equal to 0. So we're going to have to exclude those values of x that make our function in the domain or in the denominator 0. And then that ends up being our domain for the f divided by g. All right, this little note right here is kind of important. I just want to make sure you know that this right here does not mean that we have a g of x function that is equal to 0 and we're excluding that. What we are excluding are values of x that makes our denominator equal to 0. So those are the values that we're going to exclude from our domain, okay? So it's not saying that our function is never going to equal 0. Well, it's true. It's never going to equal 0 in the denominator. But just that part of the definition, I just want to make note of it. All right, using these operators, what you need to get used to is the form that they write it in. This f plus g and then of 0, that doesn't mean times 0. What this means, this translates to this right here, f of 0 plus g of 0, because what is right here is our x value that we're plugging into our functions. Okay, so to determine what the value of f plus g of 0 is equal to, is we're just going to plug in 0 and add them together. So for f of 0, take your function that you're given up here, plug in 0 to all of your x values. And then for your g of x, do the same thing. Plug in 0 wherever you see x, and then simplify that, and that is your value of f plus g of 0. So we get 0 from this portion here, we get 0 from this portion, leaving us with -4 minus 4, or 1, which equals -5. And that is our solution. Now let's look at part B here. We have f of g, or f minus g of 4. Again, don't mistake this for multiplication. It is not multiplication. So we're going to replace our x values with 4. So we're going to replace f of 4 minus g of 4. Now, be careful with this minus sign. We're going to place our minus sign around our entire function of g right here, because that negative is going to distribute through. So our f of 4 function, placing 4 back into the f of x, going to get 3 times 4 minus 4 minus our entire function of g with 4 replaced inside our x. Okay, now simplify this, and what we get is 8 minus, and all of this right here reduces to 31, and then that gives us negative 23. So here's our solution for part A, and here's our solution for part B. Okay, now let's do a multiplication and a division one with these same two functions that we were given as in the last example. Here's our f of x, here's our g of x. Again, don't mistake this for multiplication of negative 2. What this is telling us is I want to take f of negative 2 and multiply it to g of negative 2. And we're going to replace all of our x values with negative 2. Go ahead and put your function right here, the f of x and g of x, in parentheses when you do multiplication. So 3 times our negative 2 minus 4, and then we're going to multiply that to 2 times negative 2 squared minus 1, and then simplify that. We get a negative 10 times 7, which gives us negative 70 as our solution of f times g of negative 2. Now division looks like this. We're going to say f of 3 divided by g of 3. And then we're going to simplify everything after we plug in 3 for our x value. So 3 times 3 minus 4 over, then our g of x function, 2 times 3 squared minus 1. So the numerator, what that gives us is 5. And then in the denominator, that gives us 17. Cannot reduce that any more than what it already is. So this is our solution for f divided by g of 3, 5 over 17. Now, for each of these types of functions that are using operations on functions, you will receive you will receive a function of f and a function of g. They won't be the same every single time. You will get something different. And then you'll receive new x values to plug into these functions. So don't think that they're the same function every single time. You will find those in your directions, in your exercises in your book, to what functions you are using for f and g and maybe h and other sorts of functions too. Okay? Now, what we're going to do is we're going to take these functions that were given. Here's our f of x, here's our g of x, and we're going to add our functions together and just simplify it. So here's what we're going to do. We're going to say, well, this f plus g of x translates to f of x plus g of x. I'm just going to replace my f of x with what it's equal to right here. Go plug that in. And the same thing for my g of x. I'm going to take that, plug it in for here. And out will be my new function, this right here. So x squared minus 3x plus 4x plus 5. Now, simplify this by combining any like terms, and we end up getting x squared plus x, because these are like terms that combine to x, plus 5. There's our new function. Now, the domain of our f plus g of x ends up being the intersection of the two domains of our functions that we have. Now, the domain of f, of f is this right here. It's all real numbers. Now, the same thing goes for the domain of g. It is also all real numbers. Okay? If you don't know how to find the domains of your functions yet, you better get started. You better learn that quick, because you're going to have to combine them in this one. Now, the domain of the two functions added together, the domain of f plus g, is this right here. It's the intersection of this and this, meaning the domain that they have in common with each other. So actually it's going to be the smallest domain. So the smallest, or the domain that they have in common with each other, since these two are the same, the domain for f plus g is also going to be the same. Now we're going to do this with subtraction. The domain for subtraction is it's the same as adding. So I can go ahead and state the domain of f minus g is the same as what we discovered the f plus g being. It's negative infinity to infinity. Okay? So now let's look at our f minus g of x. This is just the restating of it. It's f of x minus g of x. And like I did before, I'm going to replace my functions in here. So my f of x is the x squared minus 3x minus, and remember, put parentheses around this whenever you have a minus sign, because it distributes. And now simplify. So this distributes across the parentheses, which gives us minus 4x minus 5. And simplifying that further, we get minus 7x minus 5. And that is what f minus g of x gives us. And then we've already found the domain. Dealing with the same exact functions, we're going to find f times g of x. So f times g of x is the same thing as f of x times g of x. So again, plug these in for f of x and g of x. Put parentheses around them. because we are going to be foiling this. All right, so let's FOIL this real quick. This ends up giving us, let's see, that times that, 4x cubed, that times that, plus 5x squared. The inner functions, minus 12x squared. Outer function, let's see, outer terms, minus 15x. Now simplify. We have two terms that are like each other, and we get, let's see, 7, yeah, minus 7x squared minus 15x. And there we have it. We have f times g of x. And again, our domain is going to be the same thing as our f plus g and our f minus g of x. So domain of f times g is all real numbers. Okay? Now the domain for this one changes a little bit. There's a little bit more to it. But let's go ahead and find what the function is equal to before we go and find the domain. So f divided by g of x translates to f of x divided by g of x. And this normally is the easiest function to determine because you just put one function over the other and really can't simplify any more than what you normally have right there in front of you after plugging them in. So plug this in for f of x, plug this in for g of x. And try to simplify as much as you can, but if you can't, there you go. Ta-da, that is what we get for f divided by g of x. Now the harder part on f divided by g of x is determining the domain. Now the domain, we already determined the intersection of our two domains of f and g were all real numbers, the negative infinity, infinity. But we have to exclude whatever x value here that makes this function, our new function, 0 in the denominator. So we're going to solve. Where does this denominator give us 0? By setting it equal to 0. Okay? And that is going to give us x equals negative 5/4. So this tells us we need to exclude this from our denominator. It is going to be all real numbers except for where x is equal to negative 5/4. And how we state that is just like this. So here's domain of f divided by g. I'm going to place it down here because it's long. It covers the whole x-axis except for where x is equal to negative 5/4. So we have to put a parentheses around it that tells us to exclude it from our denominator. Union it with where it starts back up at negative 5/4 and goes all the way to positive infinity. And we're done. So that's how we exclude a single number in a domain that is all real numbers in the first place, is we write it just like this. So it starts at negative infinity, goes to infinity, but excludes the negative 5/4. Here is how we're going to determine composition of functions and their domains. Whenever we have this form right here and this little circle in the middle, what this means is we're composing two functions. We're putting two functions together, one inside the other. And g of f of x, that's how you read this right here, g of f of x, is equal to this, g of f of x. So our function that is right here is going to be the inside function of the outside function. Okay, we're combining two functions together, putting one inside the other. Now, the domain of g of f is the set of all numbers x in the domain of f such that f of x is in the domain of g of x. I know that's complicated to understand, but hopefully you will get it with some of the examples that I have for you. Let's start out with an easier example of composing functions by doing evaluating a composition. Okay, so what this right here, the f of g of 2, translates to is this right here, f of g of 2. 2 is our x value that we're going to place inside of our g function. So that's what I'm going to do first. I'm going to place inside our f function 2 over 2, because I just replaced my x here with the value that I'm given here, 2. Okay, so what that is right there, if we simplify that, is f of 1. So now this is my new x value that I'm going to plug into my f of x function. So that gives us f of 1, we're going to replace x with 1, so square root of 1 plus 4, which equals the square root of 5. And we're done. So, not so bad, I don't think, at this point. But it can get more complicated. I'm sorry to tell you that. Let's do another example. So again, let's do, instead of f of g, we have g of f of 5. So our inner function is f, but here is how it reads, g of f of 5. I'm going to take my f of x function, replace x with 5, because that's what it tells us to do, but keep my g function on the outside. So square root of 5 plus 4. Simplify that. So g of square root of 5 plus 4, that is 9 on the inside of the square root. And then the square root of 9, that is 3. So what we're finding is g of 3 now. So take our g function and replace our x values with 3. We get, let's do this over here, we get 2 over 3. We can't reduce that any more than what we have there, 2 over 3. So we're done. That is that's the value of this right here. The g of f of 5 is 2 over 3. Now, we're going to compose two functions. We're not evaluating the composition of anything. We are composing two functions together. So we're going to have two functions, compose them, and we end up with a brand new function with x in it. So no evaluating, plugging in numbers for x this time. So this tells us to find f of g of x. Find f of g of x. So g is on the inside here. So what I'm going to do is take you step by step how I do these functions. Your book may not do it like this, but this is how I do it. Keep your f on the inside, on the outside, and replace your g of x with what it is equal to. Your g of x is equal to 2x plus 5. So 2x plus 5. Now, this is what we're going to plug in. That becomes our new x value. What we plug in, this is what we're going to plug in for all x's in our f of x function. Okay? So plugging in 2x plus 5 in for x gives us square root of 2x plus 5, then minus 1. Then reduce that by combining like terms. You get 2x plus 4, and you're done. That's as much as you can simplify this at this point. Now we need to determine the domain of this new function that we have come up with. F of g of x is, is now this right here, the square root of 2x plus 4. Find the domain of this function right here. We know from the past, I've told you, use your calculator to help you in figuring out what the domain of this function is going to be. Sometimes it can be a bit more difficult to figure out where on the calculator these values are on the x-axis. So I'm going to show you algebraically how to figure out the domain of a function that has a square root in it. If you come across any other type of function that you cannot figure out how to find the domain for, let me know in class and we'll cover it, okay? So here we go. Inside is how I'm going to explain how to find the domain of a function that has a square root. Now we know inside a square root we cannot have negative values. So this portion that I just circled has to be greater than or equal to 0. Okay? So really, this is our domain right here. That this right here has to be greater than or equal to 0. Once we solve this, we pretty much have our domain. Now, y'all know how to solve inequalities. Solve this by subtracting 4 on both sides, divide 2 from both sides to get x by itself. We get negative 2. Now change that inequality into interval notation, and that there is our domain for our f of g of x. The domain for f of g is negative 2 to infinity, because all of our x values are greater than negative 2. There you go. That is how you find the domain of your new function. Just look at your new function of what you come up with and find its domain. Okay, let's do this again with we have the same functions actually. Let's find, instead of f of g of x, we're finding g of f of x. There are distinct differences between f of g of x and g of f of x. They're never the same unless they are inverses of each other, and we will learn that later on. Now, we are determining g of f of x, which translates to g of f of x. This time, our inside function is f. So replace f of x with what it is equal to, the square root of x minus 1. And now, that is what we're going to place inside our x value into our g function. So 2 times the square root of x minus 1, then add 5 on the end of it. There we go. We can't simplify any more than that. That is what our g of f of x is equal to, is this right here. Now, finding the domain for this, again, it's going to be all real numbers except for wherever the inside of our function here is greater than or equal to 0. Okay? well, not except, it's for everywhere that inside of our square root function is greater than or equal to 0. Okay, so let's find values for that there by taking our x minus 1, setting it greater than or equal to 0, and solving that for x. And that is our domain. So we get our domain for g of f is going to be, starts at 1 because of this greater than or equal to symbol. We need to put a bracket around it like that. And goes on to infinity. And there we have it, our domain. These examples get progressively harder, but let's take a look at this. We are going to find f of g of x. Which is equivalent to f of g of x. Replace your g of x with what it's equal to. So f of 2 over x. Now replace your x value that you have in your function, or all x values, depending on if you have multiple x values in your f function, with 2 over x. So we're going to have 5 over, then 2 over x plus 4. All right, so here we have a complex fraction. If you don't remember how to simplify these, pay close attention. How you can simplify a complex fraction is determining its greatest common denominator. Well, in this case, everything else in this thing is over 1, so except for your 2 over x. So your greatest common denominator here is 1 times x, or just x. Multiply everything, each term, meaning this right here, and this right here. Multiply everything by x. So you get 5x over 2, because the x's end up canceling out. See, x times x, that times x, and this times x. See how the 2's end up canceling, or the x's end up canceling? So here you go. It simplifies to 5x over 2 plus 4x. Now, for this, what we're going to do is find the domain. And remember, domain for rational functions, you cannot have 0 in that denominator. All right? So we're going to say, let's find where this denominator is equal to 0. So where is 2 plus 4x equal to 0? Solve that. You get -1/2. So this is excluded from our domain. We do not want our x value to equal -1/2, because otherwise we would have 0 in the denominator. And there we have found our domain for this function right here, which is our f of g function. And remember, if you exclude one single number, you have to state everything, so -infinity to infinity, except for -1/2. And this is how you do it. There you go. That is the domain for f of g of x. All right. So, all right, this is one last example before I let you guys go. We have same functions as before, except we're determining f of g of x. Okay, and I'm going to rewrite it as we did before, just like this, g of f of x. And then replace our f of x with what it's equal to, the 5 over x plus 4. And then place the 5 over x plus 4 in for your x value here in our g function. And we get this complex fraction. Okay? Now, to simplify this, remember we can multiply the numerator here by the reciprocal of the denominator. So this one's not nearly as bad in simplifying. So we get 2 times x plus 4 over 5. And that simplifies to 2x plus 8 over 5. Now, determining the domain of this, we have to go with the denominator of the original function before simplification, which is this right here. We have to use that denominator because that's our original function, 2 over 5 over x plus 4. And we cannot have a 0 in the denominator for this function either. And what we need to do is exclude wherever, well, x is not negative 4 in this case, because we want to exclude where x plus 4 cannot equal 0, which is negative 4. So this number right here, x equals negative 4, is not going to be in our domain. And it's going to be written just like we wrote the previous one with the 1/2 or negative 1/2, I believe. So the domain, let's go back. The domain for our g of f is going to be all real numbers except where x is equal to negative 4. Now that's the last example I have. What I want you guys to do in class is pay very close attention to the problems that ask you to find the domain. You might be able to easily find the compositions of these functions, but I really want you to focus on being able to find their domains also, because you will be quizzed and tested over that. And so that's all I have for you. And please ask as many questions as possible in class whenever we go over this section's homework together. So I'll see you later. Bye, everybody.